Another neat feature about the polar coordinate system is about the naming of the polar coordinate points. Now, for example, in a rectangular coordinate system, coordinate points are unique. What I mean by unique is, take the coordinate point 2, 5, for example. In order to plot 2, 5, I need to go right 2 and I need to go up 5. So here is 2, 5. What that means is, in order to plot this point, I need to go right 2 and I need to go up 5. There's no way around it. There's no other way to get to this coordinate point. However, in the polar coordinate system, coordinate points are not unique. Now, what I mean by not unique is that one polar coordinate point actually has several different names. For example, let's look at 5, 240. 5, 240 means I go right 5 along my polar axis, and I'm going to go all the way around to 240. So here's 5, 240. Now, this coordinate point, not only can you name it 5, 240, but you could also name it 5, negative 120 degrees. Think about my negative angles. Going clockwise, here is negative 15 degrees, negative 30 degrees, negative 45 degrees, negative 60 degrees, negative 75 degrees, negative 90, negative 105, negative 120. So what this means is this polar coordinate point, not only is it 5, 240, but it's also 5, negative 120. So this is what's called similar polar coordinate points. These two are also going to be similar. So what I'm going to do is I'm going to show you guys how to find similar polar coordinate points. And there's going to be some formulas. So here's my example. What I want you to do is I want you to find 3 different pairs of polar coordinate points such that your angles need to fall between negative 360 and positive 360. Now, here's my example. I'm still going to take 5, 240. So the first formula I want you to know is the first similar point is going to be r, theta minus 360 degrees. So what that means is 5 is my r value, 240 is my theta value. So r is going to be 5. To get my new angle, I'm going to take theta minus 360. In other words, I'm going to take 240 minus 360 degrees, which means that my new angle is going to be negative 120 degrees. This new angle needs to fall between negative 360 and positive 360, which it does. Now, my next similar coordinate point is going to be negative r. So instead of a positive r, it's going to be negative r, theta plus or minus 180 degrees. Now, what I mean by plus or minus is you're going to do one or the other. So your r, you're going to make negative. So instead of a positive 5, you're going to make it a negative 5. Now, your theta, your new angle, you're going to take your old angle and add or subtract 180. Now, whatever result you get has to be between negative 360 and positive 360. So if I do 240 plus 180, it gives me a new angle of 420. 420 is way too big. It falls outside of this window. So instead of 240 plus 180, I'm going to do 240 minus 180, which means that my new angle is going to be 60 degrees. Now, my third similar point is going to be working off of my new coordinate point here. So r is going to be negative. However, I'm going to take this brand new angle that I just got and I'm going to subtract 360 degrees from it, just like I did here. So r is going to be negative, so we're still going to have negative 5 here. However, this new angle, I'm going to work off of this 60 degrees. So it's going to be 60 minus 360. I'm not going to use the 240 anymore. So 60 minus 360, we end up with negative 300 degrees. So here is one polar coordinate point, and I found 3 other pairs. So using the exact same idea, I'm going to do the next 2 examples. So 4, 135. R I'm going to keep the same. My theta, I'm going to subtract 360. So 135 minus 360